Now count to 10 and start in your head.
Hello, everyone, and welcome to the Kubernetes community meeting for August 15th, 2019. I am Chris Short of Red Hat. Welcome, all of you. This is a community meeting and will be posted publicly on YouTube, so please be mindful of what you're saying because it's being recorded and I will tell your mommy. We also have a code of conduct, so please be excellent to each other. And without further ado, I will introduce Dev Kalkarni from I just dropped the name. CloudArk. Sorry. There you go. Take it away, Dev.
Thanks, Chris. Hey, everyone. I'm Dev Kulkarni, and today I'm going to demo to you Q+. So essentially, with Q+, we are solving the discovery and binding problem of custom resources. This is a rough outline of what I'm going to do. So I have a few slides. I'll, in the first 4 minutes, walk through them and then give a demo. Essentially, if you look at as code systems, like infrastructure as code from AWS CloudFormation and Terraform, the set of APIs that this system use to create declarative, orchestrate, and create technology stacks declaratively, those set of APIs and resources is sort of pre-known. With Kubernetes, though, that is not the case because we can extend the set of APIs in a Kubernetes cluster by adding custom resource definitions or operators. And then the challenge becomes, how does a microservices developer or application developer actually discover, bind, and create technology stacks from these custom resources? And that's the challenge which Q+ is trying to solve. So essentially, we focus on multi-operator environments. We can think of it as a platform layer, custom platform layer, extended Kubernetes cluster by whatever operators we want. And the set of YAMLs, custom resources, essentially represent a platform definition as code. So if you look at the person, a microservices developer who is going to need to use these custom resources, the kind of discovery, binding, and orchestration challenges they face are what kind of custom resources exist, what are there, what kind of actions they support, and how do I bind them together. The binding may involve one custom resource utilizing another custom resource, its spec property, or some sub-resource that another custom resource creates. And ultimately, how do I essentially represent a complete set of custom and inbuilt resources as a stack? So these are discovery, binding, and orchestration challenges. And in order to motivate the sample scenario of the demo, this is the example that I'm going to use. So this example consists of a standard web application, Moodle, which is an e-learning application. It uses MySQL database as the backend, and one way to create a stack of Moodle is to use two operators, one for MySQL and another for Moodle. And the MySQL custom resource, MySQL operator manages the MySQL cluster custom resource, and the Moodle operator manages the Moodle custom resource. The key thing to note that the binding between these two custom resources happens through the spec property of Moodle custom resource, where the name of the underlying service that a cluster, MySQL cluster creates needs to be provided in order to create the stack and the Moodle custom resource to use it together. The question is, how does this an application developer discover this, and then how does the binding, can we do it in an automatic manner? So that's where Q+ provides certain things which are helpful. So for discovery, what we provide is a set of new endpoints which help an application developer figure out additional information about custom resources. And this information essentially goes beyond what can be available through kubectl explain from spec properties. So for static information, there is a man kind of endpoint which provides a way to provide man page kind of information. And for dynamic information, there's the composition endpoint. So here's a output of using the composition endpoint to figure out the dynamic composition tree of the MySQL, the cluster 1 instance of MySQL custom resource. And if you notice, as the output of this, we can see the specific service name, cluster 1 MySQL master, is one of the services that is visible as part of the composition tree. The next task is, now that I know this information as an application developer, can I somehow bind these things together in an automated manner? And for that, we provide a couple of functional constructs. So one is import value, another is add label, and what they do is they do runtime resolution of the custom resource spec properties and sub-resources. And as an example, how it looks like is, instead of, this is the YAML spec of Moodle custom resource. So if you notice in the MySQL service name, now instead of directly hard coding the actual name of the underlying service of the cluster 1 resource, I'm providing it using the import value function. And the parameter to that is a fully qualified sub-resource name. So the first part is the kind, the custom kind, which is MySQL cluster, then which is followed by the namespace and the name of the MySQL cluster instance, followed by the subkind. And then if there are multiple instances of the subkinds, then we have a filter predicate, which allows you to filter the one that you need. So finally, let's say I want to define all these resources as a group to say that this is a stack that I want to orchestrate. For that, we have the platform stack CRD. The platform stack CRD does not actually deploy the resources. It just defines the resources and their dependencies. So that's at a high level what's going on. And now let me switch to the demo. This demo is also available on YouTube. So let me see if I can, give the live demo if my Minikube fails for some reason. Yeah, looks like it's not returning. Let me just run through the video. So what this demo shows is, on my Minikube, I've already installed Cubelets, and I have installed the operators as well. So those are my Cubelets and operators. So the first thing I can do is get the man page to find out information about the Moodle custom resource instance. So I see that I can do something similar with the MySQL cluster custom resource, and get the man page information, in which you can find out information like, okay, this is the what kind of name needs to be provided, and so on. After that, we are going to create the platform YAML, which provides me a way to define the dependencies. So my Moodle custom resource depends on cluster 1 custom resource. So now I'm going to create the platform YAML. And then once I do that, the next thing is, if I try to create the Moodle 1 custom resource, then it's going to say that, okay, the dependencies are not satisfied. So now let's go and actually create the dependencies. So the one thing it needs is a secret. Another thing it needs is the cluster 1 MySQL instance. So now I'm going to create that, the cluster 1, and then we will be able to see while the cluster 1 is getting provisioned, we should be able to see the composition of cluster 1. So let's just see that the cluster 1 is getting created. And after that, we should be able to see the composition of it. And so that's my composition output. This is the dynamic composition tree, which represents all the resources that are created. And as you see, one of the resources, the service object with the name that we want to specify in the Moodle custom resource. So in the Moodle, if you look, I have used the import value function to define the binding. And then once we create it, let's just make sure that the cluster 1 is actually up. It takes about a few 90 seconds or so to get it created. So that is just we seeing the, yeah. So now we can create Moodle 1. Just make sure that sometimes there are 4 pods for cluster 1, so it takes time to, yeah. So now all that cluster 1 is running, I can create the Moodle instance so that the dependent resources are now created. And let's look at the describe of Moodle 1, because that shows the resolution has happened. So if I do a describe, yeah, the cluster 1 MySQL master, that resolution is what we were after. In the spec, we had specified import value, but then the resolution happened. So this is the main thing that, sorry, yeah, that Cubelets provides. If you under the hood, what's going on is we define certain annotations which are to be added on CRD definition. So a composition annotation which defines all the underlying resources that are created by an operator for managing a custom resource, and then a usage which essentially is a config map with whatever information you want to provide. So these are the 3 components. There is an aggregated API server which provides discovery, mutating webhook which provides binding and resolution, and then the platform stack CRD, which is just for dependency declaration. So as an operator developer, you include the annotations on CRD definition, install Cubelets on your cluster, and then application developers should be able to use the endpoints and the binding primitives to define the binding. As far as comparison with other tools are concerned, the main thing is we focus on runtime resolution in Cubelets. So what I'm looking for is input on the discovery and binding primitives. If there are any suggestions on what additional information can be helpful, would be happy to hear about that. And yeah, that's all I had. Thank you.
All right, thank you, Dev. There are links to those issues in the community notes. Please feel free to check those out if you have a moment. Next up, Lucky, I believe you have release updates for the 1.16 release.
Thank you, Chris. Hello, Kubernetes community. My name is Lucky. I'm the 1.16 release lead. News out of the release team for this week. We cut the tag for 1.16 beta 0. So we've created the branch in upstream Kubernetes, which is a great milestone for the release team. So thank you to all involved. Next week is week 8, which is coming down to the last 4 weeks of the release. So burn down begins, where we start to meet more often and burn down all the enhancements that need to go in and start getting all our ducks in a row to get 1.16 out the door in mid-September. Beta 1 is being cut next Tuesday on August 20th. And then for those who are part of the team that are writing the enhancements, code freeze is August 29th. So reminder to get all your associated PRs in and merged before the end of this month. That would be very much appreciated. As patch releases are concerned, there haven't been any cut this week, although we're targeting 8.19, which is next Monday for 1.15.3, 1.14.6, and 1.13.10. Cherry pick deadline is today. So if you have things you would like to go into those patch releases of the current supported versions of Kubernetes, you need to make sure they are merged today. Pending dates are announced on that mailing list, and feel free to ask any questions. That's my update. Back to you, Chris. Thank you.
Thanks, Lucky. Any questions, anyone? Sig Beard, anything question-wise? No? Okay, good. Then you're up, Aaron, contributor tip of the week. Off you go, sir.
Okay. Hi, everybody. I am Aaron of Sig Beard with your contributor tip of the week. No cat t-shirt today. I decided to swap out the cats for a wave of pugs, representing, I think, the way that open source software development works. I will share my screen. You can walk along with me if you would like by going through the meeting notes. So I wanted to show you today a dashboard I started working on earlier this week to try and give us some statistics about like the release blocking jobs and their health overall. So just walking through these graphs real quickly. This shows sort of the daily failure rate of the release blocking jobs. This shows the release blocking jobs that have been continuously failing for n days and how many days they've been failing for. This is the daily flake rate of the release blocking jobs. For those release blocking jobs that are flaking, these are the worst flaky jobs according to the last week. And over the last week, these are the flakes that have happened the most. So for example, I could click on this and view it. I could copy this text. I could go over to go.kates.io/triage. I could copy paste this into the test thing. The test field is a regular expression, so those brackets get interpreted specially. So I'll drop them, I'll hit enter. And now I can see like everywhere that this test has happened. And I can see that it used to be a lot worse last week. So it seems to be mildly better this week. I can scroll down and I can see, you know, some of the failure clusters like looks like something kind of flared up August 8th. And it looks like somebody has helpfully fixed this on August 14th. So we may see it drop off that dashboard. Continuing on. I can also see sort of the 99th percentile duration of the release blocking jobs, the average interval between release blocking job runs, and out of curiosity, the average number of tests that get run during each of these jobs. So I can tell, for example, that somebody's been really awesome and been adding some integration tests because it's been going up. You'll notice I have these little threshold lines here. And these threshold lines sort of represent release blocking criteria. So if I sort of take away, if I filter by sort of the max here, I notice that the basal test and the basal build jobs are the ones that are peaking up here. It turns out these are because they're post submits, so they only run when code has been committed instead of periodically. So they're blowing that threshold. I can also tell that the GCE, the serial job, is blowing that threshold. You know, it's running about every 7 hours, which doesn't seem like it's giving us really great signal. If I remove that, the remainder of these jobs are running under the threshold to be considered release blocking. So I have a PR out to address these, and I think next we should talk about how we can make the serial job something that can run a little bit more frequently. You'll see there are similar thresholds for the release blocking duration. Again, I think serial and alpha and some of the other things, maybe things we want to talk about. And then similarly here, what I'd love to be able to do is to boil this down into like, this is the probability that, you know, you're going to see a green release. And it turns out we've never had the opportunity to see a green release until we kind of go back to about June 7th is when we had like at least something wasn't 100% failed. So I'm hopeful that this provides us the opportunity to better identify like our test health, see if we can do a little bit better about it. You can also use this drop down here to filter against specific things. So like I was doing this the other day to verify just the relative health of the end-to-end job, the integration job, and the verified job to get those statistics looking like that. This list is sadly hard-coded. So any feedback on how this is or is not effective for your help can be found on this issue, and I would love to hear your feedback. I've also created an equivalent job or equivalent dashboard for merge blocking jobs to give us an idea of how healthy these things are. All the same things. These are slightly different than the metrics that are available here. It's unclear to me how helpful some of these things have been for folks. This larger dashboard here looks at everything for all repos. And it also sort of computes flakiness relative to the numbers of PRs that have seen flakes. Whereas these new dashboards that I've linked in the doc are just about the jobs for Kubernetes that either block merge or block the release. I have more links in the doc that I won't drag you through, but if you're curious about how these metrics are being computed or the actual queries, I'll just show one. You can avert your eyes, children, to see how we're getting this data out of BigQuery. You're welcome to follow up with me. This, again, is something that anybody is capable of constructing a query and putting up a dashboard on their own. BigQuery is freely available to query up to the first terabyte of data. And I found through experimentation against sort of the daily and weekly data sets, I get nowhere near that when I'm just messing around with the query. So I'll stop there. Any questions? All right.
All right.
Cool. Thanks, everybody.
Cool. I didn't avert my eyes, so I can't continue. Sorry. Bye, everybody. No, I'm kidding. Aaron, thank you very much for the update. That was very cool. SIG update time. Just a reminder, SIG leads, there's a SIG update schedule. It is linked in the notes. Please make sure you're aware of it and when your SIG is up next. The first SIG update, there's only 2 today. It's from SIGauth, Mocom. You're here somewhere. I saw you earlier.
Yep, I'm here.
Awesome. Take it away.
Let me see. I will put the actual link of the doc into the community notes once I find them. But I will first share my screen for now. If I can actually find it. Okay. All right. I think you guys can see my screen. I think I picked the wrong one, but this is okay. This is fine. All right, so I wanted to give you all a quick update. I am Okon. I'm one of the co-chairs for SIG Auth. I think Tim did the last one. Continuing with what we discussed in our last update, the overall theme of the SIG right now is we are moving features towards GA where we can. And in the more contentious approach, we are working on possibly trying to remove things that we don't necessarily think we can support anymore. Before I get on with the update, the doc does contain a poll for our deep dive for KubeCon NA, and also technically Contributor Summit, whatever people want us to do. So if anyone's interested, it's a 1-question poll with like 7 options, and you can say if you like any of those things, and it'd be very helpful for us. So now with the actual update. So there's 4 things I kind of wanted to highlight. There's the CSR API, the PSP API, some audit work, and service accounts. So if anyone's familiar with the CSR API, it's been beta in Cube since I believe 1.6. So as you can imagine, that was a long time ago now. And it is effectively an API that even at the beta level, an incredible number of production clusters rely on to function correctly. Right? So we want to push it past the beta mark and get it to V1. So to help us sort of get it there, Mike, Denise, one of the other co-chairs, he wrote a retroactive KEP for it so that we can kind of outline this is where the API is today. We know a large set of issues with the current shape of that API. We will then use that KEP to effectively define those. And that is our path towards effectively saying, okay, these are the things that we have to have in this API before it V1s. And probably the hard part of that is deciding what things can we drop and say that those will be like a V2 alpha thing. And we realize we're going to have to. There's too many things that people possibly want to do with this. So community feedback, especially around what pain points you had with using the CSR API. I think one of the most common ones is in order to use it, you're basically submitting an actual cert request instead of, for example, a lot of times you just want to have a workload and say, hey, I'm a workload and I have a service. Can I have like a cert for my service, please? Like a serving cert, right? That's much more like Cube style, like ask for something, not necessarily submit an entire like, go make your private key, submit your CSR request, all that. That's much more straightforward to what people actually care about. So that's probably one of the bigger ones. But in general, I've personally written like a custom approver for the CSR API. It's not particularly fun. It's not awful, but it's not the fun experience that I would hope it would be. So if anyone has feedback on that, we'd appreciate it. PSPs, I think we caused people great pain when we started discussing this, but we are considering the deprecation of this API. It has been at beta for a long time. There's linked slides that we have gone over a lot of the issues with trying to move it to GA and sort of the things that it sort of fails to accomplish for us. I don't want anyone to get too worried. We're not even remotely going to remove this without a very suitable replacement and a clear migration path. So some type of moving off of PSPs. It is, I mean, we could, if there was a strong desire from the community to try to GA it in some form, I don't think we're against that. There would have to be a pretty strong push from the community for us to sort of be able to find the people to do the work to do that. There's two sort of things we're looking at as possible replacements. Gatekeeper is a very early stage project for defining sort of policies that you can apply to Kubernetes. I don't think at this current point it's at the stage that it can reflect what PSPs do today for people, but they're actively investigating how they could make that a possibility. If we had wanted to go a more different route, OpenShift has had the security context constraints API for the last 3 years at a stable version. They have the same functionality as PSPs, but more. So that's also been discussed as if SECs were a standalone CRD that you installed into your cluster with some type of validating, mutating admission webhook. If people could use that to replace PSPs, we could certainly write a controller that converted all your PSPs into SECs for you. That is certainly an option as well. This one, I know people have feedback. It was one of the most requested things that we cover in our deep dive. We will do so, but please feel free to reach out to us. The next little bit, dynamic audit. I'm not going to go into too much detail on that. The link there sort of takes you to various discussions we've been having. The primary thing here is we're looking at defining all the use cases based on the various actors who would care about dynamic audit, and sort of making sure that the shape of the API can support those. Like I said, not going to go too much into it, but the docs that we have are extremely verbose on this now, in the sense of like what does a cluster owner want versus a cluster admin versus a normal user versus like an auditor or so forth. So especially if you work in like an IT security style field and you manage Kubernetes clusters and you want to sort of know what's going on in those, this is probably of great interest to you. So now service accounts. So this is probably the place where we've been doing the most. So if anyone's familiar with the token request API, Mike also made a retroactive KEP for it. This came out of the container identity working group a while back. This is how we effectively want Kubernetes service accounts to assert identities outside of clusters. All right, so traditionally Kubernetes service accounts have had long-lived tokens, but that's extremely dangerous to start sending out of the cluster, right? You don't want the entity that's validating your service account token to then be able to fully impersonate you forever. That's very dangerous. So audiences and time-based attenuation is what the token request API lets you do. And it also lets you bind your ephemeral token to the life of a secret or a pod if you so desire. So we wanted that retroactive KEP to effectively allow us to, in the same way as the CSR API, decide how we get this to V1. So it is also beta right now, if I remember correctly. In relation to the same idea of having your container identity outside of the cluster, if something is trying to validate the service account JOT token, it needs to know like what public keys to use. So a path that has been proposed is to allow the Kubernetes API server to serve the OIDC discovery doc, which defines like a scheme for like a well-known endpoint, which has a specific JSON structure for its response that then tells you how to look up the current keys that are being used. This is a little bit of a weird thing to do because Kubernetes is not an OIDC server. It is not compliant with the OIDC spec, but it would meet sort of the code and libraries and the infrastructure that exists out there today. So it's a little weird, but I think it's probably the best we can do. We don't necessarily want everyone to have to rewrite code that is effectively the same thing as OIDC discovery, just so that we are not piggybacking on something that isn't the real thing. Continuing on with that, once you do have discovery and you have the token request API, you get into the problem of, all right, I'm some external entity and I'm validating these tokens as they go by. How do I know when I should necessarily reload tokens? I mean, you can continuously keep pulling and just hammer the Kube API server all the time and keep pulling tokens. That works. It's not necessarily the nicest thing to do. So we have been considering adding key IDs to service account tokens. The idea there would be is if you see a token come by that has a key ID that you've never seen before, well, that's probably a good indicator that you should go fetch the current discovery metadata and see, can you validate this token or not? I had raised the point on this that we have always said the service account tokens are opaque, and now we're saying we're going to put a non-opaque key ID inside the token. So maybe it's time to just say that they're not opaque. We've never actually broken the structure of these tokens. They've always been JOTs. They've always had the same structure effectively, but I've always told people, no, you can't rely on that. This is just an implementation detail. So the last little bit, this is certainly a pretty contentious KEP right now. There is some desire to allow third-party signing of service account tokens. So that would mean that something other than the Kube API server or the Kube controller manager is the actor that's actually signing a token. The main concern here is this introduces a new complex RPC extension point to the Kube API server, similar to like the Kubernetes KMS API. So I think what we probably do right now is try to define what is possible with just dynamic reloading of files that helps with signer rotation, and then kind of see what are the use cases for having an external signer, and are we willing to live with the increasing complexity to get and support those use cases. And that is all I have, if anyone has any questions.
Awesome. Any questions for Mo? All right, moving right along to SIG Cluster Lifecycle. Justin, Santa Barbara, I saw you bouncing in and out. Are you here? Yes.
Hey, I am here.
Take it, everybody.
Thank you. I have turned on my video. I will share. I produced slides. I didn't know that producing a doc was an option, or I would have followed that route. I hope we can see them. Nod?
Yes.
Thank you. All right. So SIG Cluster Lifecycle. I am Justin Santa Barbara. I am a lead of SIG Cluster Lifecycle. SIG Cluster Lifecycle is, for those that don't know, effectively working on creation and ongoing management, eventual destruction of Kubernetes clusters, and everything that is involved in running the cluster itself. So sort of the components thereof. That is a broad mission. It is one of the biggest Kubernetes SIGs. We have hundreds of contributors, and there are 20-ish subprojects, multiple working groups. It acts as a home for both open source, what I would call distros, and open source building blocks for those distros. So the building blocks are sort of this idea that we are trying to create standard reusable components that are modular and that can be plugged together to produce a working a working tool to create Kubernetes clusters. We will produce some of those working tools. I'm calling them distros, but of course, there are commercial distros as well, and a lot of enterprises, for example, build their own distros. The hope is that we will provide great components that they can choose to assemble into a distro and give themselves a great head start, so that everyone basically ends up with a better Kubernetes experience and a more consistent Kubernetes experience, whatever tooling they are using. Within our SIG, we have, I would say, 5 primary building blocks. Starting from the bottom, we have Image Builder, a new project, KubeADM, which I think everyone is hopefully familiar with, etcd ADM, which is managing etcd, Cluster Addons, which is going to manage the add-ons that run on the cluster, and Cluster API, which is going to provide a Kubernetes API to manage the clusters themselves. And then we have at least 4 and possibly more distros that are acting as subprojects. Kops, KubeSpray, and Minikube. Hopefully people are familiar with those. Kind is a newer one. I think technically it's under SIG testing, but it is a great one for local Kubernetes development as well, and builds on a lot of these pieces. I'm going to dig a little bit deeper into the building blocks. I don't have as much time to dig into the distros as I've split them, but I will give some updates on what the status of the building blocks. So starting off with our newest subproject, Image Builder. Historically, the Kubernetes project did not want to produce cloud images. Cloud images are AMIs on Amazon or OVAs on vSphere, the pre-baked disk images that you boot up and effectively a Kubernetes appears. And as a result of not standardizing, we ended up with at least a dozen ways to build Kubernetes images in OSS alone. And Image Builder is a project to sort of bring sense to the plethora of ways and try to identify the best pieces from the various approaches. At least at the moment, Image Builder is a tool that enables you to create images rather than producing images as its output. So you would run the Image Builder tooling in your account and get an image in your account, rather than having an official Kubernetes AMI or an official Kubernetes OVA, at least at the moment. This is the newest project. It is very early days. Many approaches have been merged into Kubernetes SIG's Image Builder. And the work right now is around deduplicating, identifying the best bits of everything. So if you want to get involved in that, it is a great project, and early and a great opportunity to get involved. etcd ADM is pre-alpha, relatively new, not as new as Image Builder, and it is working on how we run etcd clusters for Kubernetes. This is something that a lot of people, when running Kubernetes, have trouble with. etcd ADM deals with configuration and backups and upgrades. It is adopting a sort of interesting design approach where it is starting off with a contribution from Platform 9, which is a CLI tool for very direct, easy, and safe human-driven operations. And then on top of that CLI tool, we are looking to build a sort of self-driving capability that will effectively automate operation of that CLI tool, so that, for example, if you're running in an AWS auto-scaling group, it can recover from the basic scenarios, but where you still are able to sort of step down and look at what the CLI itself is doing. So it's not an invisible black box. Early days for this project as well. The real next steps are to actually get etcd ADM integrated into KubeADM and into the distros, and also working on a lot of the functionality that's missing in self-driving, and also a bunch of functionality at the CLI level. So a great opportunity there as well. KubeADM, bootstrapping the actual Kubernetes control plane itself and the Cubelets. It is our most mature product of the building blocks. It is stable today for non-HA clusters, and it is working on HA or full HA support. My understanding is that it's in beta. It recently added support for Customize, which is a great way to enable users to make changes to the specification of objects beyond the sort of KubeADM built-in opinion. So this is a great way to, in a scalable way, enable KubeADM to be a more reusable building block, so that every distro should be able to use KubeADM. And KubeADM is actually really clever in that it can both act as a building block of a distro, and it can also alternatively run standalone to sort of produce a very minimal cluster. So I imagine a lot of people here have brought up a KubeADM cluster. And that's, having both options is a wonderful bit of functionality there. KubeADM has done a great job of having a very well-groomed and active backlog for easy contributions. contribution. And so there are plenty of ways to get involved. And I think if you want a big impact to KubeADM, integrating with the other building blocks is a great way to get that going. Those integrations are in their earlier stages right now. Cluster add-ons, again, early. This is dealing with the installation and management of these additional cluster components, things like core DNS or ingress controllers or CNI drivers. We are exploring the idea of having operators that enable specification of these in a declarative, these add-ons in a declarative way, and then apply them and sort of maintain their health and do sensible upgrade behavior on them. The goal of this is not to force everyone to use this, as with all the building blocks, but it is to produce a good implementation that is so good that distros choose to use it, but no one is, of course, forced to use it. This project meets bi-weekly, is prototyping these approaches. We're having interesting challenges around things like RBAC and what the right packaging and distribution mechanism is, and working to get integrated into other tooling. And then finally, our fifth building block, Cluster API, perhaps the most, I guess, exciting one. Another one where we initially decided this was out of scope for Kubernetes, and we ended up with a dozen ways of doing things. And so Cluster API is replacing those with a homogeneous CRD and controllers for clusters and machines, building a lot of providers that enable that API to work on various clouds, as well as Docker and bare metal. V1 Alpha 2 is very much in the works, I'd say, if not done. And it brings a greatly improved model for infrastructure and provisioning abstraction. And the train keeps on rolling. So if you want to get involved, help us plan V1 Alpha 3 and try it out on your own cloud and you know, document anything you find, fix any bugs that need fixing. And as I hopefully have emphasized, we definitely need your help. You know, the puzzle is not yet all green. We want to get there. We want to have all these pieces, you know, in GA and working well together, and all the distros built on top of all those pieces. There is a lot of work to get there, but I think we have although we have all these projects, I think they fit together very well. We believe that the 5 building blocks are the full set, but Image Builder was a relatively recent addition. I think probably last time I said we believe the 4 building blocks are the other full set. So there's always room for another building block if you think of a missing one. But please do come and help. This doc, which you can probably read in the link is already in the notes, describes how you can contribute. But there are bi-weekly meetings of the top level project, and then lots of other ways to get involved, including at each sub-project has its own meetings, Slack channels, things of that nature, and a GitHub, of course. I do want to give 2 shout outs, which I think are particularly appropriate and bring up valid points. Like, this is a massive SIG, and so thank you to everyone that contributes in the many ways that people contribute. And in particular, my co-leads, Timothy St. Clair, who did, I think, an amazing job of basically corralling these 20 projects into a sensible and sustainable way of working. And so in the main SIG Cluster Lifecycle, these projects report in and provide their status, and it's sort of a federated approach, and it all works very well. He's giving everyone best practices on how to do backlog grooming, all of that sort of stuff, helping people get new contributors involved. So he does a wonderful job of that. So thank you to him. And also thank you to Lucas, who has, a lot of people probably know him from his excellent work on KubeADM and as SIG Cluster Lifecycle lead. I believe he's going to be at least temporarily stepping away to go to university. So I think we wish him all the best. And thank you for everything he's done. And another page of links for people that want to know where to find us. But otherwise, that is all I have. And thank you so much.
Thank you. Any questions? All right, moving along. Some announcements. We are now soliciting session proposals for the 2019 San Diego Contributor Summit. If you plan to be at the Contributor Summit, please consider leading or at least requesting a session. SIG intro and deep dive session proposals are due tomorrow. Your SIG should decide on these and submit them like right now. CNCF has published the results of this Kubernetes security audit, including a set of finding documents. Those are all linked in the notes. Anyone else have any announcements before I move on? Going once, going twice. Sold. All right. Shout outs this week. Check the shout outs channel on Slack. And if somebody did something awesome for you, shout them out. Aaron Krickenberger shouts out to A. Seacom for putting in work reviewing Kubernetes test PRs, promoted to approver. And a link to a pull request. I will not read the URLs. Another shout out to Bob Killen from Aaron Krickenberger for the many Kubernetes community PRs authored and reviewed, promoted to approver. Shout out from me to George Castro for reminding me at the right time and right place perfectly to get this community meeting together this week. Thank you, George. And then E. Hashman, shout out to Guinevere Sanger for helping some folks on my team get started with upstream contributions. And when I hunt through the docs and associated issues, I keep running into all sorts of awesome improvements she led. Sparkles. And that is it. Unless anyone has anything else for this week's community meeting, we are done. Anybody? All right. Thanks for joining, everyone. Have a wonderful rest of your week. See you next time.
Happy Thursday.